In this video, we'll take a short look at some new structures that we can use now that we know about conditionals like if and how we can expand upon that. So here we're just going to write a very simple program. All it's going to do is it's going to take a single user input, which is just going to be some integer n, and then it's going to calculate the sum of the numbers up to n from 0. Here, I'll move that over so we can see it better. So for instance, if the user entered let's just say 4. So if the user enters 4, then answer is 0 plus 1 plus 2 plus 3 plus 4, which should be 10. And we're going to do this 2 ways. Actually, we're going to do this 3 ways. We're going to do 2 ways that are equivalent, and then just for the sake of teaching some problem solving, we're going to do it the better way. But just for an example, you can see that we want to be able to count here, right? We need to be able to go up to the user input. So again, first off, let's just start by getting the user input. So cout, enter a number. We'll just type that in. Capitalize that. I need to keep remembering to put using namespace standard. Actually, I guess now might be a good time to mention, just because I know it used to confuse me when I was error checking when I was first starting out in computer science, at least with C++. So it says like cout is not defined and nline is not defined. If you don't include the namespace, you can actually use things still in that namespace, and the way you do it is simply give the namespace that you want to access from. So here cout is a part of standard, and you simply put 2 colons and it will fix it. Here, just for an example, I'm going to do that. So both nline and cout are in namespace standard, which is why this works. So if you happen to go online and you see that you will get responses where it will say something about standard nline or standard cout, or the compiler says something like that, this is all it means, is it's the formal name for it when you actually give it the namespace. And when we include a namespace, it just fills that in for you. And it's common C++ practice not to use the namespace, so part of the reason I mention it, and also partially just for your debugging purposes. Anyways, let's go ahead and finish this. I need to do the same thing with cin, so I'll just standard cin, and then we will read this into an integer, which I will call n, and we will simply get that there. Okay, so now we can read the number. We want to be able to count now up to that number from 0, and we need to be able to add it, right? So I'll need to do int sum equals 0. And so the naive approach here, right, would be we check if n equals 0, then we stop the program. Else if n equals 1, we add 1 to it, and we could keep going, right? So we could check every single known number. But A, that's annoying, and B, it's very inefficient. So what we will do instead is we are going to use what's called iteration, which allows us to basically count, or allows us to go in a loop of some kind until we hit a condition. So the first thing we're going to do is I'm going to create a variable called I. This is just common to use letters like I and J for iteration. And I am going to do a statement here called a while. And what a while statement will do is whatever we put inside these braces, or sorry, these parentheses, as a Boolean expression, whilever that is true, it will keep going through the code. So here, if I was to say, let's make I equal to 0, what I'm going to do is simply type while I is less than or equal to n. And what you'll see is that this will go while I is less than or equal to n, and as soon as this is not true, in which case I is greater than n, it will stop executing this code. So first things first, what I'm going to do is let's just say sum plus equals I, and I'm going to cout I just so we can see it. And you should notice that something is going to happen here. I'll go ahead and run it right now. So we get an error, and it's because I didn't put standard cout and standard nline. I forgot I was doing that. Here we go. And we'll try that again. Okay, so I run it, and it says enter a number. And so we've gotten to this line, right? It prints the thing, and then it's going to read n, and then after it does that, it's going to sit here and loop. What I'll do first is let's just enter this number and then we'll play around with it. So let's say I do 8, and you'll see that it just keeps printing 0. And so it's going forever, right? And the reason it's doing that is because I'm not approaching this condition in some way. So something you need to consider when you're doing iteration is you may get infinite loops. So this is how we generate loops, because this is what iteration is. If you are not reaching this condition, or reaching the opposite of this condition, then it's never going to break. And so because I is just constantly 0 here, I'm never breaking. So the way I can do this is with I plus plus. So I'm going to do plus plus. I don't think we've gone over this yet. This is the increment operator. What this means is that we're going to add 1 to I. So here I have the same line of code as if I was to write I plus equals 1, which I guess is equal to I equals I plus 1. So I don't think we've gone over either of these before. This one, this plus equals, or the plus plus. But just so we can mention it, I equals I plus 1 we are familiar with, right? What this does is it takes I and it adds I plus 1. And so if I was 0, it would take 0 plus 1 and then make I 1 and then make I 2 and then etc. So here, let me just comment these out and we'll take a look at it. Just as a refresher, we can use a variable to update itself. So all this will do is it will simply count I up by 1 every single time. And you'll see if we run it, let me zoom in, that we get enter a number 8. I don't know where that's getting printed from. Oh, sorry, that's from me typing it in, right? And then it prints 0, 1, 2, 3, 4, 5, 6, 7, 8. So it counts every single time, right? That's what it does. So it goes here, it says n is equal to 8, and I is equal to 0. And what it will do, if you do a while loop, is it will simply check this and make sure that it's true. So here it will say, is 0 less than 8? And yes, that's true. So it will jump down here, it prints the number, it adds it to the sum, which we'll get to in a little bit, and then it sets I equal to itself plus 1, which means that it's just going to count by 1 every single time. And hence why we get this counting. What these two lines of code is exactly the same as this. They all count upwards. And so if you're doing something where you need to count a number, make sure that you're either doing something where I is getting added by a number or I is subtracting by a number if you're approaching a lower bound. Otherwise, you're going to generate an infinite loop. So I plus equals 1 is a way to do I equals I plus 1. Whenever you do an operator where it just has the operator and then equals, what this will do is it will add the number or the expression on the right-hand side to the variable on the left. So here when I do I plus equals 1, what that means is that it's going to take I and add 1 to I and then overwrite I with it. This also works with minus, so you can do minus equals, you can do times equals, you can do divided equals, and you can even do mod equals, I think. And I believe the same things apply to Boolean operators, if I'm not mistaken, but I don't see why you would really want to use those. Anyways, that's what I++ does as well. I++ specifically counts by 1. It's called the increment operator. And just as a comment, we'll say these 3 lines of code all count by 1. One other alternative we have to I++ is ++I. And they essentially do the same thing. They both make I go up by 1. But the difference between these is the order that they go in. So ++I comes before I++. And ++I is also higher in precedence than things like multiplication and division and addition and all of that stuff as well. What this essentially means is that ++I in our order of operations comes before pretty much everything else. And what that means is that I will get updated before it executes anything else in the line. Whereas I++, it will wait until the end to do I++. Now, with these two lines, it doesn't really matter what the difference is between these two things, but if you were to write something very complicated where you threw an I++ in there, then these are going to do fundamentally different things. We'll leave it at that for now. If you're curious, you can look these up. One is the increment operator and one is the pre-increment operator. The ++I is the pre-increment. For the time being, I'll leave it at that. We also have access to, I guess just to mention it, I minus minus as well, and whereas I plus plus makes something go up by 1, I minus minus makes something go down by 1. Anyways, this should do the same thing if we were to run it. I'm not going to right now, but it will just count from 0 to 8 because it will go through each time and make I go up by 1 each time. Now let's just go ahead and take a look at the sum now just to make sure that our program works. So the sum is equal to, I need to make sure I put standard line, is equal to sum. And so we said here, if I enter something like 4, then the answer should be 10, because 1 plus 2 plus 3 plus 4 is 10. Okay, so I run it, it says that, I'll enter 4, and you'll see that we do get the sum is 10, because 4 plus 3 is 7, 9, and then 10 if we add those up, and then the 0 doesn't matter. So this seems to work. It goes through and it counts and it gets all of them. Now let's do an alternative to while, and then we'll do an alternative to that as well. Here, let's go ahead and do the alternative to while, which is a for. Anything you can do with a for loop, you can also do with a while loop. A for loop is mostly just here for convenience. So a while loop, remember, what it does is it checks this condition, and if it's true, it will execute this code, and every time it hits the end, it will go back up here, check it again. If it's true, it will run the code again, and then keep checking. And if it's false, it breaks to the end. And so it exits the code block. For will do the same thing, it's just a bit of a shortcut. So what for allows us to do is it allows us to do a variable declaration. So a for has 3 parts to it. The first thing is a variable declaration, which is optional. Here I'm just going to do the equivalent of the I equals 0 line with j equals 0. So the first line allows us to create a variable or set a variable. You don't necessarily have to do int j equals 0. You could do something like I equals 0 as well, and it will simply take this I that already exists and set it equal to 0. Just for practice, I'm going to do it this way. And then the second thing is a condition. So this here would be the same condition that we had before, so j less than or equal to n. And then the third thing is what gets executed at the end. So here, the first thing, and I guess notice that each are semicolon separated, so they are exactly like writing normal lines of code. You basically get to write 3 lines of code in the for loop, and they always come in the same order. So the first part is an optional variable declaration. The second part is the condition, which is what we check. So this will get checked every single time we do a loop. And the third part is gets executed at the end here, at the end of an iteration. So each time it loops through the code once, it will execute this last statement. So this is equivalent to this one, essentially, where j is just replaced with I. This part, this int j equals 0, is equivalent to the int I equals 0 that we have on the top one. The j is less than or equal to n part is equivalent to this part right here, and the j++ is equivalent to this part right here. So if you know you're going to count, this is just a common way to do it because you know you're going to need all 3 of these things. You'll need a variable, you'll need a condition to check, which we need for all while loops, and then we also need a condition that's going to happen, or not a condition, but an expression that will get evaluated every single time we end a loop. And so a for loop does that, and it's just very convenient to do. So here I will print a for loop thing just to show it. So here let's print standard cout, and I will print starting for loop. I'm going to put an end line here too, just to make it more readable. End line, I think I accidentally deleted a colon, and then we'll print one more end line after that. And then the rest of the code that we have from the while loop, I will simply take and throw into here. So it will just print all the numbers again and take the sum again. Now, if I do this, I should probably set sum equal to 0 as well, just because we're going to be taking it a second time. So here we go. I'll set that there. And if we run it, we should get the same sum both times. Actually, I deleted the first sum print statement, so we're only going to get it once, but the for happens second, so we're going to assume that this is going to do it correctly. And you see that it prints starting for loop 55555. Ah, and the reason that is because I'm printing I, but J is the one I'm looping with here, right? And so we went to sum plus equals J. Sorry, we were using I for the for loop. I'm using J here for, or sorry, I for the while loop. I'm going to use J for the for loop. Now if I type it in, there we go. So it prints the 0, 1, 2, 3, 4 from the while loop that we had earlier. It prints the 0, 1, 2, 3, 4. So the for loop does exactly the same thing as the while loop, and it prints the sum is still 10, so it gets the right answer as well. So these are really just the two easy ways to do iteration. And there's only one more, which is just a variation of the while loop, and that is a do while loop. So a do while loop is like a while loop, but it only has one difference. And so here I'll do that. It's actually no parentheses. You put do, and then you put the block of code, and then you put a while afterwards. And you won't really ever see me do this in my code, but I feel like I should mention it so you're aware of it. What this does is it does a while loop where it checks the condition every single time. So it checks this here. I might need a semicolon. I don't know if I have the right syntax for this. My apologies, that is me forgetting. It does have a semicolon after it. So do, and then a block of code with the braces, and then while, and then a semicolon. Will do a while loop normally, but the difference here is because the while is at the end instead of at the top like when we normally write it, rather than check before it runs the code, it will run the code and then check. The main difference between that and the first one that I wrote is that because it doesn't do the check till the end, it will execute whatever code is in this block before checking. So the main difference is that it runs at least once, even if the condition is false. So runs once at bare minimum before checking the condition. So if there's something where you for sure want to run it, but you still want to do a while loop, then this would be an example of that. Now I'm going to comment that out. We don't really want it, but I figured I would mention it so that everybody's aware of it. Okay, so last thing let's talk about is how would we approach this problem without a for or a while loop? And that just has to come down to our actual math ability on this one. So here we've been adding up all the numbers just one by one, right? I want to give a quick explanation as to why you should never actually do this and why you should search for solutions to problems instead of just trying to do it what we would call the naive way, which is just the kind of the like the first thought that would come into your head, right? If I told you to add all the numbers from 0 to n, where n is some number, you might think first, well, okay, I'll just add up all those numbers one by one, which is what we're doing here, right? We added, for instance, with the 4, 0 plus 1 plus 2 plus 3 plus 4. Now, that is not good from a computation standpoint because we're going to have to add up n many numbers every single time we do this calculation. However, there is a shortcut to a problem like this, and if you've taken something like discrete math, you might already know the answer. It's the Gaussian formula for stuff like this. So let's just take a quick moment to look at that. I'm sorry we're going to have to throw in math here. Feel free to skip it if you aren't interested in the math, but we'll go ahead into that. Okay, so let's take, for example, the one that we were just doing, which was to add up all the numbers from 0 to 4. I can kind of ignore the 0 in all of these cases because it doesn't really do anything, right? Now, the strategy for this, one way to go about thinking of a shortcut to this is to add things that are kind of like symmetrical around the middle of it. So this is like the middle of our addition, right? If I was to add 1 plus 4, it's 5, and if I was to add 2 plus 3, it's 5. So we end up having 2 5s here. And that might seem a little weird as to why I'm doing it. So let's go for a bigger example. Let's say I wanted to add up all the way to 100. Again, I'm going to throw out 0, 2, 3, and then 4, and then we do dot dot dot, and then we do 96 and 97 and 98 and 99 and 100. Now, if I asked you to do this, what you might do if I asked you to add it by hand is you would say, oh, well, 1 and 99, those add up to 100, right? 2 and 98 add up to 100, 3 and 97 add up to 100, 4 and 96 add up to 100, and etc. So if I did 595 and all of that, until I get to 50, which is not going to have any partners. So I'm going to have a bunch of 100s, and I'm going to have this 100 at the end, and then a 50. So what you might do is you might say, well, how many numbers are there from 1 to 49? Because that's how many matches there are going to be, right? All the numbers from 1 to 49 are going to match with another number from 51 to 99. So there are 49 of these, and they are going to be each 50. So we're going to have 49 groups of 50, plus the 50 that's in the middle, and then plus 100. And so if we combine these two, right, this would be 1 times 50, and this would be 49 times 50, so I can combine them to be 50 times 50 plus 100, and just really quick, this would be 2500 plus 100, which is 2600. I think that's right. Maybe I made a mistake, but hopefully not. So we got an answer, but maybe the more important thing here is the kind of the intuition that we're matching things up on both sides, right? And the other fact that because we're matching up things on both sides, we end up getting half of the number of things that are going to match up to whatever number it is that we're adding up to. So in this case, we got 100. Ah, no, I made a mistake. I'm sorry. 99 plus 1 is 100, not 50. It would be 100 there. So this would be, I'm sorry, 50 times, I'm terrible at arithmetic apparently. We have 49 times 100 plus 1 plus 100 is 50 times 100 plus 50, which is 101 times 50, I guess, is one way we could look at it. Which is fair enough. That is the right answer for sure. Okay, so that should be, I guess the number doesn't really matter. We could add that, we could do it on a calculator, and we would find out what it equals. But going back to what I was saying before, the intuition here is that we kind of match up the numbers here, and they end up equaling to 100. And we kind of end up matching things that are symmetrical, and we get half the number of things that there are of that number. So here we got 50, which is half of 100, and we can kind of intuitively figure that out. So here we actually got 2 5s, right, which is half of 4. So we seem to be noticing some sort of pattern here. So I'm just going to do this with some blocks here. So let's say I was to write these out as blocks. So I could do 1 plus 2 plus 3, etc. So dot dot dot. Let's say I only add up to 3. Now 1 plus 2 plus 3 is equal to 6, right? That should be equal to 6. One way that I like to imagine this, just in my head, for proving this more mathematically, is let's say I took this same picture and kind of flipped it upside down. So what I'm going to do here is I'm going to draw the same image, and it's going to be the same 3, 2, 1 looking stairs, right? So we have 1 on top, and then 2 on the bottom, or it's like 2 in the middle and then 3 on the bottom. So it's the same shape as this one on the left, but it's like flipped and moved to the side. The one thing to notice here is that the top row is always going to line up, and it's going to be, I'm going to erase the 6 now, it's going to be 1 more than the total height of the tower. So the height of the tower originally was 3. So this is 3 tall, which is the original height of it. And then this one is going to be 3 plus 1 tall. Let me do that in the same color. Right, because it will always be the same as the bottom of the tower, and then this is going to be the one from the top, which the top always starts with 1. And the same thing on the other one, it's going to be the same length long, right, which is 4. Now notice that if we wanted to find out how many total squares in this, it would be 3 times 4, which would be 3 times 3 plus 1, and then I have 2 equal parts here, right? So if I wanted to find the total area of this, it's going to be 1 plus the number I have times the number I have, and then split in half because I have 2 equal parts, so divided by 2. And if we look at that, we would get 3 times 4 is 12, divided by 2 is 6, which is pretty interesting. And this happens to work for every single number. So if I had something that was n long, and I ended up lining it up, then we'll get the height of the thing will be n for whatever number n we do here. So this one we had 3 blocks on the bottom, right? If I did 4, you'll notice that every time I add one, it makes this length one longer, and I would be adding to this side as well. So it would make each side one longer. Again, you could prove this in a better way in math. I guess I'm just kind of trying to give an intuitive way. But we will always get a shape here where we're going to have 2 equal parts. We can split into 2 parts, and the dimensions of this rectangle are going to be n by 1, or n plus 1. So one way we can add up numbers from 1 to n is to simply do n times n plus 1 divided by 2. And that's a shortcut to it. If we go back to 100, you notice that n divided by 2, so n here is 100, right? We want to add up all the numbers to 100. N divided by 2, so 100 divided by 2 is 50, and 101 is n plus 1 because 101 is 100 plus 1. So this formula, you can trust me, does work. We could prove it mathematically that it does work every single time. Just kind of a coffee shop discussion, just that it works. Anyways, why am I saying this? Why am I forcing you to listen to me talk about math if you were interested for a problem about iteration? Well, we did a for and a while loop here, right? Where it's going to have to add up all the numbers. So for instance, if it added up to 100, it's going to have to add up 0, 1, 2, 3, all 100 numbers. If we use a formula like that, so if we derive a formula, then it's much faster, because if we consider what this has to do, so I'll put some alternate, well, let's just say I'm going to do int here, some alternate is equal to, I'm going to put this in parentheses, n times n plus 1. I think I don't need this one here. N times n plus 1 divided by 2. Consider what this does is it just does an addition, multiplication, and a division. That's 3 operations. And they're all integer operations, which are fast if you know stuff about hardware. This is way faster than looping through things, right? So just, I guess as a heads up is the reason I'm doing this. The intuitive or the naive solution to a problem is not always the best one. So consider looking up solutions to problems, or sitting down and thinking, you know, do I know math that might be able to fix this and make it easier, instead of just relying on whatever programming structure you know, right? So not everything directly translates to computers exactly perfectly. Anyways, we'll do a more in-depth example in one of the later videos for a for and while, and how we can use it for things other than counting. So please check out that video when it comes out.